All right, cool. So, first of all, just want to say thank you to everybody. Oh, Laura, are we recording?
Yeah, I'm recording.
Okay, great. Well, first of all, guys, I just want to say thank you very much for all of your participation in this project. I've just been very impressed by how much work you guys have put in, all the research you guys have been doing, all the questions you've been asking. It's amazing. And just like I said before last night, like this is pretty much a bottleneck portion of the project. The tech leads have to go in and kind of set up the foundation for everybody to be able to jump in and start working on the code itself. And so, if you feel like you have dead time or that you're not contributing, don't worry about that. There's plenty of stories to go around. Uh, the tech leads just need time to make sure that everything's up to speed before everybody else can start jumping in. And this is actually typical of enterprise work as well. Typically, the tech lead would be working on the project before everybody else comes on board, and then once they bring everybody else on board, then everybody starts, hitting the ground running. Um, so I just want to give just a little round of applause to the tech leads because man, you guys are awesome. I really appreciate it. I'm very impressed with you guys, and yeah, just keep it up. Um, okay, and so for the next part, I wanted to hold this meeting just to talk about like what is Bug Wars, what are the expectations for it, and that way you have a better idea of what you're going to be working on. So what we're going to be covering is the Bug Wars UI, what kind of screens you should be looking for in the app. I'm going to explain the Bug Wars custom programming language. So there was a little bit of confusion before when you play this game, okay, you're not playing it with a joystick. You're not playing it with a controller. You're playing it as a programmer. Okay, so the game players are actually programmers, and what they're doing is that they're programming their bug using our own custom programming language. They're programming their bug to be able to survive the environment. Okay, and so when you pit this AI against another AI, you're then going to see who's going to win, who's the better AI, who's the better programmer, basically. So that's the premise of the game. Okay, we're going to then cover extreme programming. So extreme programming is there's agile, right? Agile methodology is the software development lifecycle, which basically means what is the process that a team follows to actually create software. It's not. It sounds really intimidating. It's not intimidating at all. It's basically you do a few meetings and you follow a specific process and you just keep repeating that. And if you keep doing that, um, that's your software development lifecycle, right? Like that's how you iterate towards making the product a completed product. And so what we're going to be doing is called extreme programming, which it sounds like a buzzword, but and it kind of is, but it's very popular. And if you actually bring this up to your interviewers, they will know what you're talking about. So extreme programming is a flavor of agile, and extreme programming requires a few things: pair programming, specific meetings, and test-driven development. So extreme programming is all about a focus on code review, collaboration, and testing. And it's all about high quality code. Okay. So we're going to be following that. The shop that you go into will probably not follow this, but that's okay. Extreme programming is going to give you all the principles and tenets that you need to be successful, regardless of what your shop does. Okay. Then we're going to discuss the agile meetings and principles. So we're going to talk about like how are we supposed to set up these meetings? What are your expectations for this? Because the closer you guys follow agile, the closer you're actually going to follow enterprise. And the closer you follow enterprise, the better prepared you're going to be when you actually hit the workforce, and the more confidence you're going to have when you actually go into an interview. All right. And then finally, how we're going to discuss how to use the dev portal with Agile. So I put a lot of work into the developer portal, and Chris Rat's about to also put a lot of work into it as well. So thank you, Chris. But we're tailoring this app. Like I had a developer ask me, how come we're not using Jira? How come we're not using Trello for this? Right? Very good question. And I kind of like thinking like, yeah, why the heck did you not do that? There's so much work. But the reason I'm doing it is because I want to tailor this to new developers. Like this thing, It gets rid of all of the the fancy features that those other applications bring. It gets rid of all the fancy features that confuse you, because Jira and Trello, all those different applications, they're meant for production team, like product managers. They're meant for executive management. So they're looking at reports. They're looking at productivity reports. They're seeing how you're doing, type of thing. So it's made for different audiences. This app is made specifically for you guys so that you understand how you fit into the grand scheme of things. And so when you jump on, when you actually get started with like an enterprise company and you start using Jira and Azure, the DevOps tool or the board tool, like you're not gonna feel lost. You're gonna know exactly what you have to do to make sure you get the job done. And then finally, we're going to talk about local dev and prod environments. So as part of us mimicking the enterprise work experience as much as possible, we're going to be creating our own environments, and I'll be explaining those at the end. Okay. Any questions before we continue? And I don't see. I can't. I'm on my. I'm out. I'm in a basement right now. I'm not at my original or like my regular workspace, so I don't have multiple monitors. So if you have any questions, Laura, can you please let me know?
Yeah, I'll pop anybody up who has a question.
Oh, okay, cool. Thanks. All right, let's keep on going. Okay, so Bug Wars. Bug Wars is a programmable game. Okay, so bugs are controlled by AI and they battle against each other in a top-down view. Players write the AI using our custom programming language, and the bugs have to navigate obstacles like walls, food, other bugs as they try to survive. Okay, and these other bugs are trying to kill them too. All right, so bugs can attack other bugs, instantly killing them. And for that, the bugs have to be looking at another bug. And if you do kill a bug, the bug turns into food. So you're going to see like a little food icon there. Excuse me. You're going to see like a little food icon there. And if another bug eats that food, it will spawn a new instance of that bug. Okay. And so this is all autonomous. Like you write the scripts, everybody submits them into the main into the database, and then when somebody starts the game, all they do is they select the scripts, and then they watch the bugs fight each other. All right. So to create this game, you don't need that many views. Okay. So this is from the UI side. You really only need a game menu, a game lobby, a gameplay view where you actually see the game being played out. You need a script editor, which is basically going to be like an IDE for our language. And then you need a credits and about us page. Okay. Let's go through all of those. So I want to preface this like these are not wireframes. Like these are just general concepts. You have full reign on how you want to make the game look. Okay. In fact, I want you to have full reign on how to make the game look because you got. I can't wait to see just what kind of creativity you guys can come up with, or the time. I want to see your creativity. Like I know you guys are going to come up with crazy awesome stuff. Okay, so do not follow these as wireframes. This is just giving you a general idea of how you want to lay out the UI. In fact, if you want to change some of the wireframes because you think it's better if you set it up a certain way, go for it. Okay. So the first one is the game menu. So you see on the left, you can, and by the way, you don't have to use this logo. I just generate this one pretty easily. You create your logo, put it at the front, and then you're gonna have your game menu. The first button's gonna be play game. The next one's gonna be a script editor, and then the third one's gonna be your credits. Okay. And I don't know how to incorporate this, but I'll leave it up to you. You can play the game without logging in. Okay, so anybody can just play the game, and when you click on play game, you go to the game lobby here, right? And so for the different species, so these are the maps. You can hit right or left it's a carousel. You can hit left or right to just select a different map.
Hey,
Okay, and
Jerry,
then once you, yeah, go for it.
Ethan's got a question. Do we
All right,
already
go for
have
it.
the bug assets?
No, no, you do not have the bug assets. You're creating this totally from scratch. Any other questions?
I don't see any.
Okay. All right, awesome. So this right here is the game lobby. There's you can have like a map. This is a map select view, right? So you can hit right or left. You can select a different map. There's different spawn points here for all the different bugs. And here you can see that in this map there are 4 species that you can select. Okay, and so what you want to do is you want to be able to hit the drop down, select one of the scripts that one of the players wrote for that species, and then once you select the players, you can then hit start game, and then you'll then go into the gameplay engine. I just want to make a note though, like to play the game, you don't have to log in. Okay, like anybody can play the game and then just select a species and then just watch the gameplay. You need to log in if you want to save your scripts. Okay, so this is the part where I was a little unsure on how to deal with this. Okay, because you want to make if you want to make the menu as crisp and as simple as possible, right? You don't want to put too many options on there. So I mean, I'll leave it up to you to figure out where to put the login and register uh, um, buttons or how you want to incorporate that. But in essence, you need these 3 things. These are the most important views: play game, script editor, and the credits. Okay, play game. I just kind of briefly went over with the game lobby. The script editor we're going to cover on the next slide, and then the credits. I really want to cover credits. Very important. I don't know if you guys want to call it credits or about us. I'll leave it up to you to call it whatever you want. But the credits page is your page. Okay, you're gonna you're gonna have a page that has a picture of you, a little bit of a bio. So it's gonna have the bios of the whole team, hopefully looking really good with your pictures, like your headshots, and then you want to explain what you're doing. So you can then create like little diagrams where you're talking about the different environments that you're spinning up. You know, the local dev and prod environment. You could talk about your pipelines. You could talk about how the architecture of the entire application is laid out. I want all of that stuff diagrammed, and and again, you have free reign over it. But I want all that stuff diagrammed so that when you take this into an interviewer, like you could just show them on your phone, like, yeah, this is the app that we're working on. It's an AI game, and you can even show them the diagrams themselves, and you can talk them through it with the diagrams and also through the gameplay itself. And then when you show them the credits page and they see your picture, they're definitely going to know that you made it. So that's kind of like that's the objective here. We want to showcase your talent. Okay. And so we're going to the next slide. The next not wireframe, the next example here is the gameplay. This, oh when I made this, I was like, oh my gosh, this looks bad. But you guys got to make this look better, okay? So uh, since we want to go with mobile, maybe we can do like a widescreen view, right, where they can hold it in landscape mode. I don't know. I'll leave it up to you guys how you guys want to do that. If you do it like this, that's fine too. I don't care. But what you want to do is you got to have some sort of gameplay screen, okay? And so here's the map that was selected. Here are the 4 bugs that were selected. And what happens is every instance of a bug, okay, is running your AI script, okay, or the AI script that was selected for it. And so there's a predefined number of ticks that you can run. I'll leave that up to you to decide. Let's just say it's 200 ticks. And so for the game engine then starts playing turns. Okay, so for the first tick, it'll execute the first command of the bug wars or the script for each of these bugs, and like one of them could be like move forward, another one could be like turn right, this one could be attack, so he's attacking nothing, and then this guy could just stand still. And with each tick, a new command gets executed, and then the bugs start, moving around, and it looks pretty cool. So at the end of the timer, at the end of the tick timer, basically, you're going to end up with either bugs of different species still remaining on the board. At that point, you then calculate who has the most bugs, and the whoever has the most bugs, that's going to be the winner. Or there's going to be a bug that's just left standing on their own, maybe even before the timer runs out. Once a bug eliminates all the other bugs, then it should automatically be declared a winner. Okay, and if you could see here, there's like walls and stuff, so there's obstacles in the way, so the bugs have to be able to navigate throughout the environment using the script that a player wrote for it. Any questions? Okay. The next view is going to be the script editor. So this is the part where you have to log in, okay? Because as a player, you want to be able to register, create an account, log in, and then once you're logged in, you can then be assigned, or you can then save your own script. So your script editor. So let's say this is just a simple CRUD UI. So these are all of the scripts, and then these are all the names of the scripts that the player has already created, and so they can go in and edit them if they wanted to. But then they also have the option here of creating a script. When they create or edit a script, they get taken to this view, and it's going to have the script name here, okay, which by the way should be unique. And then over here, here's the actual source code for the code itself. And there's going to be
Eric,
two buttons. Yeah, go for it.
just a quick question. What about
Yeah.
this project makes it AI specifically, or is that just a kind of a way to
Oh,
save the script?
it's the way to say the script, and it's not AI. And everybody uses AI in the wrong way. Well, no, it is AI. It's AI in the sense that you create the AI to control this bug. Um, but it's not the AI that we imagine now with like ChatGPT and
Right.
having the whole. This is like gaming AI, but it's still a legit use of the buzzword, so might as well use it, right? Or you can use it whatever you can use. You can define it however you want. Like you have complete reign over this. This is me just throwing out an example and like only putting in like these wireframes were done with like in an hour. So like you can change it however much you want. Okay. I just wanted to give you the general idea.
Yeah, no problem. Thank you.
Yeah, no problem. And so here with the source code, okay, I've seen some teams do some really cool stuff with this. Like they made it like a true IDE. So you were able to type in your commands, you typed in your label, and then they will underline it with red squiggly line if something was wrong. It was awesome. It was so awesome. So you have once you get well, I'll explain that in a little bit, but you will have the freedom to be able to do that kind of stuff if you want uh, in the months ahead. Okay. Now, I did want to include here this compile button. There has to be some sort of compile button that tells the user that their script will actually run. Okay, because if I misspell something or I use the labels improperly, or we're going to go over the rules a little bit, but there's going to be certain things that if they don't do right, you're not going to be able to convert it into bytecode. Okay, and so you need some sort of mechanism that kind of tells them, hey, something is wrong with your script. So I really like the IDE portion of it, where with that one team that did it, because they did it in real time. They were scanning your text all the time, and they were then able to give you real time feedback. You don't have to do that. If you just want to put like a compile button just to see if it actually runs or not, you can go ahead and do that as well. Okay. And then save. This actually saves this raw text to the database. Okay. And I found that the best way the best way to store the AI script itself is as raw text, because you're always going to have to get it back and edit it anyways. Okay. So you want to save it as raw text, but when you're actually selecting it for gameplay, that's when you compile it and convert it, and then you can then play the game with it. All right. Any questions? Okay. So playing the game, we're going to I put that I messed up completely there. Okay, so let me just show you an example of the commands that we're going to have here. Okay, so right here, let me see if I can get this bigger for you guys. Okay, can you guys? Okay, that's better. All right, you guys see this? Okay, let's see here. I forgot one command, and it's going to be the no-op command. All right, there we go. Okay, so this is the Bug Wars scripting language right here. Okay, there are going to be 6, 7, 8, 9, 10, 11. There are 12 commands that you're going to have to implement. Okay. And so these are going to be the syntax rules for how you're going to actually write a script. Okay. So let me just go over these commands a little bit, and then I will then we can then talk about how you would actually write a script with it. So the first command is called no op. No op means that you don't do anything. So as soon as this thing execute, as soon as this command, if this command gets executed for a bug, the bug will not do anything. He will just sit there and do nothing. Okay. The next one is called move. That means that the bug is going to move forward. So a bug has to be let's do this real quick. So a bug should be, it's going to have a specific orientation. Okay, it's either going to have north, it's going to have, let's see, east, it's going to go south, or it's going to go west. Okay, so a bug has a specific orientation within the map itself. And so when you do move, you're going to want the bug to go left. All right, so move means move forward. This thing's going to go left. And so if you're tracking it with the XY coordinate system, that means that the X value has to be decremented by 1, and then the Y value stays the same. Okay, so let's say it was here and I didn't move, then the bug would then move over 1 bug, and you would see it in the gameplay. And if you want to actually animate it going from here to here, by all means, please do that. You don't have to do that though. This is where I'm going to explain this concept of MVP, which is called minimum viable product. You want to get something functional to the customer, and then let the customer decide what you want to do, what should be done next. Okay, so you're not trying to build the Ferrari up front. You start out by building a skateboard, and then you let the customer tell you how much what direction they want you to take with the app itself. Okay. So so move is move forward. Rotate right is rotate right. So basically, so ROT right, that's rotate right. That means you're going to have the bug rotate to the right, and so now they'll look in the right direction. Rotate left, or ROTL is rotate left. You're going to then have the bug rotate to the left. So that's pretty straightforward. The next one is ATT. That means attack. So wherever the bug, whichever direction the bug is facing, when they attack, the bug will attack the square adjacent to it. Okay, and if there is another bug there, it will kill that bug. And if there is food there, then the bug will destroy that food as well. Okay, and then the next command is going to be eat. So if you have food here and the bug is facing in that direction, and you call the eat command, the bug will then eat the food, and then you will then generate another instance of the bug, and I'll let you decide the rules on which orientation it spawns. Some people say that, or some teams like that spawn in the same direction. Other teams made it spawn north. I mean, I'll leave it up to you to figure out how to spawn that. But this bug then gets spawned here, and then it starts executing that AI script at the first command of the AI script. Okay, so like this guy can be on command line number 5 of the AI script, and then this instance can be on command line 1 of the instance. And so that's where the randomness and that's where you see the even though everything is like predetermined and everything is ordered with the AI script, like everybody's running different commands at this point, and so it looks chaotic at that point. It looks organic. Any questions so far? Okay. The next ones are going to be the conditionals. Okay.
Hey, Jerry.
Yeah, go for it.
I just wanted to ask. I assume that all of the conditional stuff in the go-to will not like be part of your turn, right? That's stuff that can happen,
Correct.
right? So only commands 0 through 14 would consist of a turn, right?
Yes, correct.
Okay.
Very good. Very good observation. Yes. In fact, if you wanted to, and this is something that your team can discuss. So basically, at the end of the day, this is what the customer wants. The customer wants a deterministic game that's fair. Okay, and what does that mean? That means like don't introduce randomness in this. if you have two scripts on the same map fighting each other, the result should always be the same no matter what. Okay. If you introduce randomness, then you're not going to be guaranteed that the bugs will. You're not going to be guaranteed the same result. Okay. And the reason I wanted deterministic is because you can now do replays with that. So basically, what you can do is, if you saw like this really great game, you can then share it with your friend and tell them like, oh, check this one out, and then they would be able to load up the same map, load up the same AIs, and they'll see the exact same game that you saw. Okay. Um, Later on, if we add more flavors, we can add randomness if you want, but you're gonna have to add some sort of mechanism to seed that random number so that it is still so it is still deterministic. That way, you can always share the replays. Okay, I went off on the deep end on that one, so I apologize for that. As far as and my other point is like we can make it so that somebody could just write a bug that just attacks every turn, right? That thing is that kind of defeats the spirit of the game. So if you wanted to, you could penalize a player for attacking an empty space or just attacking in general. So what other teams did is they introduced penalties. So like for instance, a move command doesn't just take one tick; it actually takes 4 ticks. So the move command has the bug waiting 3 ticks, and then on the 4th tick, it can then move forward. Or an attack can have a bug do the attack on the first tick, but then have a delay of 3 ticks after that, where they're not doing anything and they're immobile, so they're not vulnerable at that point. So you guys can discuss that as a team, how you want to incorporate anything like that, if you want to incorporate anything like that. But the thing is, the customer wants it to be fair. So try to come up with rules or gameplay rules that don't favor like the top right corner as compared to the top left corner. Does that make sense? Like everything should always be fair, even the maps. Like try to make the maps fair too. Okay. Um, all right. And so now let's go on into the conditionals. So the conditionals, just like Christopher was asking, is the conditionals should not take time because it's like the bugs looking left or right, or like it's like the bug evaluating its environment. Okay, and so you're gonna have a bunch of conditionals in there that kind of has the bug figure out what is around its environment. Okay, so the first thing is if enemy. So this if enemy conditional is a command that if there is an enemy in front of it, then you then want to go to a subroutine level. So basically I'll explain this in a little bit, but basically if there is an enemy in front of me, I want you to do this. Okay? And then that will tell the bug to then go do another algorithm. All right? If there is an ally in front of me, I want you to then go to the ally subroutine. If there is food in front of me, then I want you to do something with it. It could be like if there's food in front of you, you can attack it to destroy it. You can eat it, which is probably the most favorable position, right? Uh, you can I don't know, you can do whatever you want at that point, right? If there is an empty spot ahead of you, you can then walk forward. If there is a wall, um, so if there's like a wall or an obstacle in front of you, if wall should be turned true, and then if there's a wall in front of you, then maybe you can tell it like, oh, I got to turn around or something like that. Okay. If these conditions are not true, okay, so if there is not an enemy in front of you, then this subroutine is not executed, and then you go on to the next line of code. Okay. So dictates how you're going to this is going to dictate the choices that the bug makes within the code itself. And then go to here is going to be like go to a subroutine. This go to is not a conditional. It just tells the instruction pointer to then go to another line of code to start executing. Okay. So let me just give you an example. It's a lot, but let me just give you an example of this. Okay. So right here is code, and we're going to put in a comment here. The comment is going to be attack. This guy attacks twice. rotate right. Oh, this guy's not even doing anything. Attack. We're gonna call this random bug because he's doing weird stuff. Okay, so he's not even doing anything. We're gonna call him head spinner. Okay, because what he's doing is he attacks in his first on the first tick, right? Then on this next turn, he attacks again. All right. Then on his next turn, he's going to move forward. Okay. On his next turn, he rotates to the right. On his next turn, he rotates to the left, so he just stays in place. And then on the next turn, we see one of these conditional statements. So he's going to go to label, and so this label right here matches with this label right here. And so what this is doing right here, this is like saving the spot in the code that you can then redirect to. So he's going to attack, move, rotate right, rotate left, and then he's going to go to the label. So he's going to go back to the label, which is here, and then run the next command after that, which is attack. All right. And so does anybody have any questions on that so far? Okay. So let's talk about the syntax here. All right. So a label should be in capital cases. Okay. So let me just talk about this real quick. Labels. A label should be all capitals. Okay. So if it's not all capitals, you're gonna have to throw an error. Okay. A label, when you declare a label, it should be there should have a colon at the beginning of it, and it should be the first line, or it should be at the very first character of that line of code. Okay, so declaring a label should have a colon and should be first or left edge of, or should be first line of, no, first character of line. Okay, so if you had something like this should be invalid. Okay, if you have it like this, then this should be good. All right. You're gonna have white space here, right? Anything that's a hashtag. So if you put a hashtag, anything to the right of the hashtag is considered a comment. So you can then ignore it. Okay. When you so these are the different mnemonics. These are your different commands here. You want to keep them lowercase. They are case sensitive. You want it to be case sensitive. So you can't put capital A, capital T, or anything like that. It has to match this language. It has to match this. And the reason for that is because we want to make the rules so rigid that anybody, like I can write a script for team A or team healers, right? And I could take my exact same script and play it on the team Night Owls game. And then maybe we can have like a tournament to see whose script can actually win in all 5 of the games, which that would be pretty hard. It's pretty crazy. Okay. Let's see here. Okay, right here. So go to label right here. These labels, so when you do a go to label, like this label has to exist. So if you don't declare label here, like let's say I have a typo here and I put label 2, then this should give you a syntax error because there is no label that has been declared that's called label 2. Okay, so let's write that. You can labels should start. Labels can be alphanumeric, but they must begin with a character. Okay, so you can't just do to label like this. You want to make sure that it's label. You can put other numerical values here, but just make sure that it starts with a character. Can be alphanumeric plus underscore. We can add an underscore as there, but they must be begin with character. Okay. Let me see what else there is. Comments. So hashtags. Anything to write. Hashtag is comments. Anything to the right can be ignored. Let's see here. What else do we got? Let's make this a little bit more complicated. So we're gonna I'm gonna show you guys what how to use that subroutine that I was telling you about. So let's look at something here. So like if something is food right here, right? So if there is food, then I'm gonna want to go to eat. So here I'm gonna have another routine called eat, like this. And in here we're gonna have him eat. And then once he eats, we're going to have him turn around. I don't know why, but we'll just have him turn around. And then at the end of this, we'll have him start. We'll have him go to start. So we'll put a start here. I'm going to change this here, and I'm going to change it black dot. Okay. So so what happens is when they start the script, he's going to attack. The bug is going to attack again. Then the bug checks, is there food in front of me? Yes. So if there is food in front of him, then the bug will then go to the eat routine here. So the instruction pointer will then come over here, and then it'll start running. It'll then execute the eat command. Then the bug will then rotate to the right. Then the bug will rotate to the right again. And then on its next turn, it's going to go to the start, and then it'll try attacking again. Does that make sense? Everybody cool with that? I'll leave. I'll give some time for questions.
Hey, Jerry.
Yep.
Question regarding the labels.
Yes.
So in previous example, like the previous one you posted in general chat at some point, you had the label on its own line, independent of any
Yep.
actions.
Yep.
Is it all right if we still implement it like
Yeah.
that? I mean, I
Yeah.
assume, right? Because like, I guess it could be either way, right? You could support
Yeah.
either. I just think it's cleaner to have an action on a different line, because the label might be of arbitrary length and push an action way out to the right or something.
Oh yeah. Yeah. No, that's cool. It won't. That's actually what I was thinking about that when I was talking about it. It won't affect the code at all whatsoever because you just need to make sure that the index that's saved for it is still for this command. So yeah, you can keep it on its own line. You're good no matter what. And I'll explain what that means in a little bit. Does anybody have any other questions? But thank you, Chris, for the question. That was good. Yeah, you can have a label by itself too if you want. Okay. So if you are not familiar with assembly language is the low level language that controls a CPU, the CPU chip. So it has its own programming language. And whenever you compile a language like C# or C++, you're compiling all of that code into assembly so that so that the CPU can actually execute your program. Okay, so we are kind of doing the same thing. We are creating our own programming language, our own little mini assembly language. Okay, and the way an assembly language works is every command is represented by a number. Okay, so a CPU cannot process this text the way it is. It's not. It's a computer. It runs ones and it works with ones and zeros, right? So how do we convert this raw source code into a format that the computer can then read? Okay, and so the way you do that is through bytecode. Okay, and so I say bytecode and I say we're using an integer array. Like I'm using them interchangeably. And you don't even have to make it an actual byte array. I had a team say like we should make it a byte array so we can make it a legit bytecode. I'm like, okay, yeah, that's cool. But like when I say bytecode, I'm talking about the machine code, the real machine code in so like this is just a parallel example. Like we're making a simulation of assembly language and we're compiling this code into machine code that our game engine will then run, right? It's not even really machine code because it doesn't take electrical circuits to run it. It's just that's the way our game engine reads it. So when I say machine code or when I say bytecode, like I just mean an array of integers. All right, that's all I mean. Okay, but I use that term because that's how it actually is with the real assembly language. Okay, so if the way you want to make the way you actually make this a program is, let's say I have a script that says I want to do a move, I want to do a move, and then I want to do attack. Okay, so all you do is you go back and you look at these commands, and then you figure out which number corresponds with it. So in this case, if we wanted to write this, we wanted to convert this, or we wanted to represent this script as an integer array, all we got to do is go 10, 10, and then attack is 13. So it'll be 10, 10, 13, like that. Okay? And that's it. Straightforward. All you got to do now is you take this, you give it to your game engine, and then the game engine will say, okay, this bug on this game engine is going to do a 10, which means it's going to move. Okay, great. Next tick. This thing's going to do a move again. So it's going to move forward. Great, got it. Next tick, it's going to do a 13 attack. Okay, I'm going to have that bug attack. And then the program ends at this point, right? So I'll leave it up to you as developers how you want to approach this. Because once you reach the end of the program here, it's done. So at that point, the bug shouldn't be doing anything right there at that point, right? So like after the third tick, at this point, the bug's just sitting there not doing anything. Do you want to make it so that the instruction pointer comes back over to the beginning? So do you want to make it so the game engine automatically goes to the beginning and runs the script for that bug, right? That's you kind of helping the player out. Or do you want to punish the player for not putting in a proper loop in there and making it so that the bug just stays there and he's pretty much fresh meat for everybody? I'll leave it up to you on how you want to do that. Okay. But if we were just looking at this straightforward, like the program would end at this point because you ran the first command, the next tick you run the second command, the third tick you run the third command, and then after that there's nothing left to process. And when I say instruction pointer, I just mean like the spot where the spot where the program is at. Okay, so like when you let's say you have bug A, and then you have bug B, right? And they both have the same script loaded for them. Bug A can be like at index 1, right? That so you would say the instruction pointer is at 1, slot 1, and then this one the index could be at 0. So you would say the instruction pointer for this one is at 0. That's all it means. It's just the index. Okay? So bug A is at the second part of the script and bug B is at the first part of the script. Any questions? Okay, get the questions out of the way right now because now it's going to get really crazy now. It's going to make your head hurt potentially. So please get the questions out before we go into the craziness. Okay, let's do it. All right. So, how are we going to? So then the question is, how do you do conditionals? Did you have a question?
Yes. So like all the bugs are when they're looping through their integer arrays.
Yep.
For all the moves, it's tied to the ticker timer. So
Yep.
does it mean all the bugs are kind of like going through their integer arrays like at the same time?
Yeah, everybody's going through at the same time. Yes, but they're not at the same index. Okay, some can be at 0, some could be like at 5. It just it depends on however. Like let's say somebody spawned in the middle of the game, they're not going to be at the same tick counter as the rest of them. You get what I'm saying?
Gotcha. But like as the tick moves, it means that the integer is going to go to the next
Yes,
in
exactly.
the array. Gotcha.
Yep.
Okay.
Yep.
That's it. Thank you.
Yep. Cool. Awesome. All right. Very good question. Thank you. Okay. So, anybody else have questions? Sorry if I'm going too fast. Like, I can't see anything, and I just.
Oh no, you're not going too fast, but if you guys have a question, just type question in the chat and I'll pop you up to speak. You don't have to type a paragraph first.
Good point. Thank you. And Laura, you've been awesome. Everybody, please, you gotta give a shout out to Laura. Like, you're awesome, Laura. You've helped me out so much. Oh my gosh, this would
Oh,
not be the same.
I don't feel like I've
This
done anything but thank you.
so awesome. Um. Okay, so like. Okay, so now we're gonna do the conditionals. Okay, so mapping is pretty straightforward, right? So move is 10, 10, 13. There it is. We finished our program. But we have special logic now where we have go-tos and now we have conditionals. So how would you actually write this? How would you write the code with the conditionals? Okay, let's do that. So let's go through this real quick. Let's go through this. Let me just copy this and put it at the bottom so that we can be near our stuff here. Okay. So so the first one we're going to start with the start. So the first one is going to be attack. So it's going to be attack 13. And then we're going to attack again 13. And then we're going to end up with if food eat. So what we want to do is we want to do if food. So if food is 32. And what happens here though is this eat, we don't know where this is actually supposed to go yet. Because this is supposed to go to this eat command down here. Okay, but the problem is we don't know how to get there yet. So I'm just going to put a question mark there for now. So 32, if there is food there, it should go to another command down here. But the thing is, I don't know how to get there yet. But I'll show you how we can calculate that. So we're going to have 32 question mark. Then we're going to have move, which is a 10. Then we're going to have rotate right, which is 11. Then we're going to have rotate left, which is 12. Then we're going to have a go to start. So go to start is 35. And then we got to figure out, how do I go back to the beginning? Well, if I want to go back to the beginning, all I have to do is just go back to index 0 at this point. Okay. So go to start, I'm just going to put a 0 there because I want to go to the beginning where this attack command is. Okay. So does that make sense? Good. I'll take that as a yes. And then the next one is going to be our eat command. So we're going to have eat here, which is 13. Notice that we are now reached our label of eat. So this eat label lives at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, index 9. So what we want to do is we want to replace this question mark. So we want if food, we want to go to location 9. Okay. And so if there is food, it'll go from here to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It'll go here. Where our oh, did I put the wrong one here? Yeah, I did. My bad. It should be 14. I'm sorry. That's pretty cool that we highlighted and it showed us that it was wrong. Okay, so if you go here to this 9th index, you'll then go to the E command and then you'll process this like normal. Then after this, you're going to do a rotate right, which is 11. Then you're going to do another rotate right, which is 11. And then you're going to do a go to start. So go to is 35. And then we got to figure out what index, where is this first command at? This first command is at 0. So we're just going to put a 0 here. And now this is the bytecode for this. This is the bytecode now for this command. Any questions? Okay.
I feel like this is
Yeah.
deceptively simple, like you explaining it right here, and it seems so easy.
Oh shoot! It's a stuff of nightmares. It's gonna confuse people.
Yeah.
It confuses me still. Like I'm going through, like, what the heck is this? I mean, you saw me make a mistake. If I didn't catch that, if I didn't just double click and catch that, like, it would have been. I would. That was a bug right there. Okay, so it looks straightforward. Oh, but here's the thing. Here's the deceptive. Laura, you're right. It is deceptive. how do you figure out what this thing's supposed to be? How do you know what this is supposed to be? This is actually where the problem gets pretty difficult. How do you know what that's supposed to be? And how do you know what this is supposed to be? Okay. How do you know that I'm supposed to go to number 9 for eat? Does that make sense? How do I know that when I go to start that it should be at the 0? How do I know when over here for go to start, how do I know I'm supposed to be at 0? For this go to start, how do I know I'm supposed to be at 0? That is the question. So I'm going to help you. I'm going to give you an algorithm here. This is spoiler alert. If you do not want to hear this and you want to solve it yourself, you
Hey,
can.
sorry, Jerry.
Yeah, go for it.
I have a question, and I
Yeah.
missed the first 20 minutes, but
Mhm.
so maybe this was answered. Is this like a bash file? Is this just all this gonna a text file, I guess, where
Yeah, it's going to be in your script editor. So there's a page called the script editor. In your
Mhm.
web app, there's going to be a script editor like view where it's just a text box and you can go in and start typing all this code. And when you save it, you're going to save it to the database exactly like in the format that they saved it. So it's just like a text file, but it's not really a text file. You're just saving it to the database basically.
Oh, okay. So like all of these commands, there's gonna be a database that sort of sets this all up and
Yeah.
the user inputs it. Cool, gotcha, thank you.
Yeah. The user inputs it, saves it, and then they can always go back and retrieve it whenever they want.
Okay, gotcha. Thank you.
Yep. Okay.
You can go ahead and tell us that algorithm that you were worried about being a spoiler.
All right, here's the spoiler alert. Okay. So, so here's a hint on this. You want to figure out like where is this label supposed to be in relation to all of this, right? And so there's a reason why I split these. Not only did I split these up because these commands are actual like action commands, and these are more cerebral, logic type commands or conditional commands. These right here all require a target. So it's going to be if ally X, if enemy X, if ally X, if food X, if enemy X, if wall X, and then go to X. So because all of these require a specific target, you know that the size of these commands are going to be of size 2. What do I mean by size 2? If you look at goto requires one integer, and then it requires a target. So that's 2. If you look at if or that was goto. I'm sorry. If you look at if empty, which was the 32, or no, what was it? If food. So 32 if food, 32, and then the target. That's 2. If you look at goto 35 question mark, that's 2. 35 question mark, that's 2, right? If I look at the attack command, I only have a 13 here. So that means that the command is only size 1. And if I do the next attack command, I have another 13. The size is 1 at that point, okay? So what you want to do is, at the beginning, you already know that this start is at 0. So the 0 is actually easy. But what you want to do is you want to keep track of where your instruction pointer is going to be as you go through this program so that you can figure out where this eat is then going to be located. So if you do that, you can look at is equal to 1 plus this attack plus the 2 of the if food eat plus the 1 of the move plus the 1 of the rotate right plus the 1 of the rotate left plus the 2 of the go to start. And if you add this all up, it should then give you the location of where this eat is at. So if you do that, it's going to be, what is that, 4, 5, 6, 7, 9. So we end up with 9, which is exactly where we want it to be. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8. Oops, did I get that wrong? 0, 1, 2, 3, 4, 5, 6, 7, 8. Did I add this? Did I add this right? 4, 5, 6, 7. Shoot.
You have 5 ones and 2 twos, so that's 5 plus 4, so it's 9.
Yeah. So maybe I messed up here. So 13 is attack. 13's attack. If food, 32 question mark. Then I have the 10, which is the move. Rotate right. Rotate left. 35 is go to start. Oh yeah, eat is over here. Yeah. Whew. Oh my gosh. Okay. Yeah, because eat is line 14. Eat is 14 right here. So eat is 14. So that's this command right here. So we want to know where this command is, right? So we can go 0, 1, 2, 3, 4, 5, 6, 7, 8. I was confused by the question mark. 9. We want this guy because that's the eat, which is right here. And so if you go through and you do that and process it, we can put in start equals 0, like that, right? And then we can process it and eat equals 9, right? So then when we go through and start injecting values in here, we'll see that if food eat is a 9, so now we can put if food 9, which is going to be, this will then be a 9 right here. Okay, so how do we do this? All right. Can anybody give me does anybody want to give me some code to do that? I just gave you the algorithm. Can anybody give me the code for it? If you're on, Ethan, I'm looking at you. Anybody? How do you go through and keep track of the index based on all
You
of
add
this?
it to a map.
You add it to a map before that.
Yeah.
Before you add it to a map, how would you want to do it? Well, let me give you a hint. So we skipped a step here. First of all, what you want to do, like, first of all, you have this, like, you have all of this code here, right? And you got to first be able to parse it. So what we're going to do is we're going to parse this code into tokens, okay? And so what do I mean by a token? So what you want to do is you want to break all of this source code into something that the computer can manage. So we have our start token. So you want to make it in a list of string, right? If you make it a string list, we can call it tokens, and we can do a new array list. You then got to go through and read through all of this stuff to see what tokens are there. So we're gonna add to the tokens. We can add start. We add attack. We add attack. We ignore this part here because it's the comment, or it's comments, right? So we keep on going through trying to get tokens. We're gonna get if food. We're gonna get eat. We're gonna get move. We're gonna get ROT right, ROTL, go to, start. We're gonna get eat. We're gonna get eat command, ROTR, ROTR, go to, and then start. And that's the entire, that is all of the tokens there, okay? And so what you wanna do is you wanna then go through this and start figuring out where your labels are. So this right here declares your label, okay? So you're gonna go through, and if you find a colon start, you're gonna add this to a hash map. So you can make a label map. It's going to be a string and it's going to be an integer. Okay. And then when you get to colon start, you're going to have a counter at the beginning. So you're going to have, let's just call it instruction pointer equal to 0, right? So you're going to have a loop that goes through this. And then when you get to start, you're going to, if you find a label, then you're going to do label map dot put, and then you're going to put the label with the instruction pointer. Okay. And so once you do that, so it could be something like this. It could be something like if token begins with, I'm making stuff up. It might not be legit code. Okay. This is like pseudocode. So if token begins with colon, that means it's a label. You're declaring a label, and then now you can put it into the label map. Okay. If it's not, then that means it's either a command or it's another label. Okay. So we're gonna go through. Not a label. It could be a target. Okay. It's either a command or a target, like right here, right? Like these are targets. So if you see the colon, you know you're declaring the label. You want to then calculate what the instruction pointer is there. If it's not equal to it, if the token does not, if it's not a declaration of a label, then you go through and figure out what command it is. So if it's attack, so I'm just going to use pseudocode. If token is command and so if token is command and token is action command. Let's just do it like that. Let's token is action command. Okay. Then in here, I'm just going to increment the instruction pointer by 1. Okay. Else, if token is conditional command, then instruction pointer plus equals 2, right? Else, you don't do anything. Basically, if you get a target here, oh yeah, cool. So instruction, so 0 token. If it's an action command, you increment it by 1. Oh yeah. You don't want, yeah. And then you just keep looping. So you just loop through all the tokens. So else, so basically this right here is, this is a target you can ignore. Okay, so this is what I mean by this. So if it begins with the colon, that means it's a map here. You're going to want to declare it. Or that means it's a label being declared. You're going to want to save it into the label map. And then you're going to want to see, you're going to say whatever the instruction pointer is at. Then you're going to go to the first command or the next token. Is it a command? It's an action command. That means increment the instruction pointer by 1. And what that means is, oh, I'm going to the next command. What that means I'm going to start at, I'm now at index 1 at this point. And that's all what this code is. Like this code is a little is more complicated than what it looks like. Or this code is looks more complicated than what it really is. So I'm starting at index 0, 1. Then I figure out, oh, I'm at 1 here. Starting at index 0. Then I'm at 1. Then I'm like, oh, this is going to take up 2 bytes. So I got to add 2 to the instruction counter. So now I'm at 3. So the move will be at 3 here. I add 1, so I'm at 4. Then I'm at 5. And then this one is adding 2 again. So then I'm at 7. Wait up, I'm messed up here. So 0. This is 1, 2, 4, 5, 6, 7, 8, 9. And so the instruction pointer should start at 9. This is an example of me talking and just screwing it up. But the logic's all here. Like it's all here. Let's just do it again. So I'm at 0. So I'm at 0. Instruction pointer is at 0. If the token is an action command, which it is, instruction pointer plus plus. So I'm at 1. It goes through again. If token is action command, add 1. So yes, I do. So now it's at 2. If a token is conditional command, I add 2. So now I'm at 4. If token is a label, a target, I can ignore it. Yep. I go to move here. So token is an action command. I add 5. Rotate right. I add. Now I'm at 6. Rotate left. I'm at 7. Go to is a conditional command, so I'm at 2. So I'm at 9. I go to start here, which it ignores it. Then here is colon eat. So if token begins with colon, that means I'm going to put eat in there, and the instruction pointer is going to be 9. Yeah, it all pans out. Any questions on this? It's one of those things with deceptively simple, but you can already see where I'm fumbling through it just because there's just so many moving parts,
Hey,
even though it
Jared,
looks so simple. Yeah, go for it.
I have two questions.
Yeah.
First question is, I'm not really seeing the need to, I guess, convert things into like a number array.
Mhm.
I guess I'm curious why. Like, I could see that being beneficial if we were storing, the code in really small, um, sort of compiled, right, like byte arrays or whatever you want to call it. But in terms of this, right, like since we're saving the entire, pseudo assembly script anyways, why can we not just, as we're parsing the script, just like make an array of, first class functions, because eventually when we run this, right, we're going to say, okay, well, an attack is 13, so
Mhm.
13 is going to
Mhm.
call an attack method or something, right? Why can't we just store an attack method in an array directly instead of having that middle step?
Very good question. It's just the exercise itself
Okay,
of
yeah,
being
just
able
an academic
to.
thing.
Yeah, it's an academic thing. Yeah.
Okay. Second question. So far I'm not really seeing any reason. So I guess my question is, do we need to have the game logic running on the server? Because right now I'm not seeing. Again, like, it seems like all that needs to happen right now is the
Yeah,
server needs to store the script, but the client could be, simulating the games.
I would, it's because you can cheat with the client. I would say so. There's different ways of dealing with this. The more advanced way would be to have the game setting up like a socket, which would then, in real time, the server will process the game itself and then give back real time feedback.
Yep.
But I'm not looking for anything crazy like that. And this is just such a small problem mathematically that you can just submit the game, like in the game lobby, you just submit the game and say, "Hey, I want to play with these scripts." The game processes every single turn and then returns it back to you. So you get an array of 200 game turns, and then the UI can just render that.
Okay, but you do want that happening on the server.
Oh yeah, 100%. Because like I said, you can cheat on the client.
Yeah, I guess, like, you know, my question for that would be, like, to whose benefit, right? Like, if you're cheating on the client, it's really just you seeing that result. Like, unless we're storing statistics for
Yeah,
games or
yeah,
something.
yeah, yeah. Eventually, we would want to. I mean, that's so like I didn't cover that, but like there's going to be two phases of this. The first phase is just us working on this very generic, very simple logic here. But if you really wanted to, we can then expand on this, and then you guys can start adding even more commands. So we can add like jump, we can add like teleport, we can add like in infest. I don't know. There could be all sorts of crazy things that you guys can add to this. Um, that yeah, that could. What was your original question? I forgot the point that I was trying to make. So
Just,
yeah.
the need for preventing cheating, I
Oh
guess.
yeah. So like we can then add more and more, and then also that was going to say you can add more features, but you can also add like statistics where you can have like a leaderboard. You can start
Sure.
keeping
Yeah.
track of wins losses with the different AIs, and then from there you can start. It's more bragging rights at that point. But once you introduce that, then yeah, cheating is you got to find a way to combat that.
Yeah, that makes sense. I also think down the line it might be interesting to have sort of a lobby where two players could queue up with their scripts and then, like,
Yeah, that would be
over
awesome.
WebSockets, like, do it in real time.
Yes, that would be awesome. That would definitely be cool. Um, maybe adding randomness to it. I mean, this is more like we were talking about before. It's kind of like an academic project. It has roots in academia. Like the one paperwork I sent out, I think started at Cornell. I forget which university. I actually worked on this project at Ohio State, so this is something that they're using in their curriculum. And I enjoyed it so much that I wanted to bring it over to you guys as well. But I'm shoehorning this into the whole web app architecture because thinking about this is like, why the heck would we not save this as files? We could do like blob storage and save these as files. Why would we want to put this in the data? I'm even questioning my own architectural decisions on this, but it's solely academic and it's all about just making sure you understand. It's all about solving real world problems with the tech stacks that you already learned, and then trying to incorporate that in an enterprise like type environment. So And I guess with the feedback of you guys, if you guys don't like this project or you think it doesn't fit, then we can always after this, if you want to keep on going, we can just swap to another project. So I'm always open for suggestions and feedback. Thank you, Chris. That was good. And the thing that I really enjoyed about this project is that you understand now that once you write your own programming language, it helps you so much in seeing the limitations of like Java, and it shows you the limitations of JavaScript. Like you'll begin to see how the syntax, why they chose the syntax that they chose, and it makes things a little bit more intuitive as well. All right. So let's keep on going. We got a lot. We covered a lot. Does anybody have any other questions before we continue? Okay, I did not get to finish my slides, so I apologize for that. We're gonna have to go back to good old Paint. Okay, so what we're gonna cover today is going to be Xtreme Programming. Okay, so Xtreme Programming is a flavor of Agile. Okay, and the reason I wanted to do this is so that, or the reason I want to use Paint is so that Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so let me just clean this up real quick. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Get this out. All right, and okay. So we have our calendar here, right? And let me go ahead and just make this calendar real quick. And we're going to cover a sprint, okay? So a sprint is going to be 2 weeks, okay? So we'll call this a sprint. So this is one sprint. Okay, and then you guys started, let's say this was Sunday. You guys actually started on Saturday, right? So let's just put Saturday here. Saturday, Sunday, and then it goes all the way to Friday. So Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. Okay, and so what we did here is you're going to have a meeting called the sprint planning session. Okay, so this right here is sprint planning. And what sprint planning is, let's see if I can make this smaller. There you go. So sprint planning is the portion that where you select your stories. Okay, so if you go to Crusader Games here, this local. Let me see if I can find the local one because I have a new option here. Local host 8080. Okay. So the first meeting that we want to talk about is the sprint planning session. Okay, and you guys covered that. We did a little bit of that last weekend. So this right here is your product backlog. So your product backlog has everything that you want to use. All of the jobs that you have to do to create the entire app is in your product backlog. And we discussed a little bit of these. Like you have your lobby screen UI development, implement bug movement and interaction, handle bug interruptions like attack, eat, and reproduce, configure your CI/CD pipeline. Like all of these things are, and you have like a bunch of these. Okay, these represent all of the items that would require you to complete the app, and it's also all of the new features that the customer wants you to add, and it's always evolving. People are always adding new stuff, and the customer's always adding new stuff on there, and you're always you want to have that thing filled up so that you always have work, basically. So the product backlog is all of the features that you want to get implemented. Okay, then you're going to have your sprints. So your sprints represent all of the intervals of work, and it's 2 week time frame, right? Represent all of the 2 weeks of time that you want to be able to, do some work. It's like the amount of time that you have allotted for some specific sprint stories. Okay, so in this case, we have a sprint from 9:04 to 9:15, which is pretty old. So I'm going to create a new sprint, and so I have a new sprint starting from December 16th to that ends at December 30th. Okay. And so what I want to do is I go to the sprint backlog here. And when I go to this sprint backlog, these are all of the stories that I want to work for the next 2 weeks. Okay. But it says here, sorry, your cards are at another castle. Visit the product backlog to assign cards to this sprint. Okay.
Okay, I want to
Questions?
commend your graphic there. That's amazing.
Okay. Thank you. Thank you. We try. I run it by my meme council, which is Yoon. So props to Team Unity.
Represent.
Yeah. So when you get to your backlog, you want to then start selecting. You want to choose the work that you commit to, that you're going to get done in that 2 week time frame. Okay. So when you go to the product backlog here, you're going to then select some of these stories to be sprint 4. So I'll select this story to be sprint 4. I'll select this story. Let's just say we're going to work on these 2 stories for sprint 4. And so when I go back to the sprint backlog of sprint 4, I'm going to see that they are right here. Okay. So back to this. That's what's being done in sprint planning. In sprint planning, you're choosing which of these stories you want to put in the sprint backlog. Okay, and then the reason I'm showing you the local build, this is not the real build yet. I want to show you that we are there. You want to then prioritize them. Okay, so you prioritize the stories based on importance, and then once you do that, then you can then go into the sprint task board and actually start the work for the next 2 weeks. Okay, so it's very important. You want to prioritize it in the sprint backlog, saying, okay, this is we got to work on this guy first, we want to work on this one next, and so on and so forth. And I have to explain something real quick. At the sprint planning meeting also, you assign story points to your stories. Okay, so this is what happens. At sprint planning, the product manager comes in and they're talking to the team, and they start asking the product manager starts asking the team, okay, we want to start work on the game engine. Okay. And these are the stories that we have in place. So we can go back here to the product backlog. We want to start working on the game engine. Let's actually, I'm going to do not assign to all of these just to kind of show you what an actual sprint planning meeting is. So the product manager is going to come in. They're going to look, hey, we want to start the gameplay right away. But before we do that, I think we're going to have to do a lobby screen UI, just so we can get that up and running. We can select the maps. You can select the AI, and then from there we can then go on into the actual gameplay itself. So you guys take a look at this, and we figure out lobby screen UI development. You want to design and implement the lobby screen for game setup, and we want to allow users to choose maps and scripts for each species. Oh shoot! Well, let's actually look at what that would entail, right? So if you go back to this right here, and we look at the game lobby here, you guys tell me, what do you think we'll actually need to get this thing implemented? What kind of steps do we have to do? Like, what do you guys think?
So I mean, you'll need to build out the front end, obviously, like
Yes.
not
Yeah.
just CSS, but also interactivity, but then also how that, and also, I mean,
Yes, it's a
make
lot.
choices. Are you going to go to a different page when they,
Yeah.
well, drop down menu, whatever. You're going to have
Yes.
to make the things that they're going to look at and choose.
Yes.
I mean, yeah, you
Yeah.
have to build it out from front to back, basically, unless
Yeah.
you
So
do village.
y-
But
this is where we call minimum viable product. So MVP is equal to minimum viable product. Like you don't want to build the Ferrari up front. You want to build something functional, but it doesn't have to be crazy, right? So what we can do is instead of calling to the backend, we can make it so that we're going to hard code. So we're going to hard code for species of bug, right? And then so Chris, back to your point of like, and if we wanted to hard code for a species of bug, we literally could just put in bytecode in there instead of the actual raw source code, just so that we know that we can have that for the actual game engine itself. So like this could be like one way you would want to do that. So we hard code for species of bug, right? So that we can have select one of them from here. We're gonna have to implement the dropdown. We're gonna hard code. We can hard code 2 maps just to showcase that you can actually move this left and right, right? Then you're gonna have your carousel, and then we want to implement start game, and then the start game will just go to an empty screen. So when as we start talking about this, right, you want to figure out like, okay, what's acceptable for now that we can get done? What's the customer happy with that we can get done right now, and then we can then iterate on it going forward. If the customer does not want you to hard code stuff, right? Let's say they think like, no, I want a fully functional, I want a fully functional drop down where I'm calling the database and I'm getting the actual script. That's going to cost more. That means you got to start planning for that. Well, if you actually want to connect to the back end, then that means we have to well shoot, we got to do our backend service, right? We need to do so we want to do a backend. We need to do a get AI controller endpoint, right? Then you're going to have to update your service logic. Then you're going to have to add your DAO method of getting it. Then you're going to have to, if does the table even exist? You're going to have to create the table. You're going to have to populate entries. So as part of this, people are talking about like, okay, well, what has to actually be done? And so when you start discussing all of the details that have to be done, right? And you're giving these to the customer. So like, well, if you want to actually go all the way to the database and do all this stuff, it's going to require all of this. You then try to score the story. So when you go, let's go back to here. So when you go to story points, you want to score them based on 1, 2, 3, 5, 8, 13, and I put these kind of to be facetious, 21 and 32. But these are the Fibonacci sequence, okay? So you can only give a story one of these points, okay? You might hear the word like t-shirt sizes as well, like extra small, small, medium, large, extra large. It's the same concept, but from the shops that I've been at, they all use the numbers. Okay. And so what you want to do is you want to start ranking the amount of work it would take to actually create this story. Okay. So in this case, so the story here is design and implement the lobby screen for game setup. What does this actually mean, right? Design and implement the lobby screen for game setup. Uh, we can we could talk about like breaking the story up into like, well, before we do that, let's talk about what scoring is. So one story point one story point is easy and takes 1 day. So think of one story point being it takes 1 day. Okay. 2 story points is something a little bit more difficult, and I would say something that takes between this is very debatable. People are gonna if people who know agile were listening to me, they would probably shoot me. Like there's a very specific definition, but it's still very subjective, and everybody always debates about it. Okay, so when people are ranking story points, you rank story points on what you think the difficulty is, and also on the ambiguity of it. Okay, so it could be something simple. It could be something that could take a day. But if you're like, if we've if something goes wrong, it's going to take a long time to fix that type of. If you have that hesitation over something, you can add even more story points to it. Okay, so a story is rated on difficulty, on ambiguity, and also on the amount of work. Okay, so let's say something's easy. Let's say you have to change a string. That's easy. But what? Let's say, but now let's say you have to do it 200 times across the entire app. Oh shoot, that's a little more difficult, right? So that's all of those things have to come into play. Okay, when you're setting up your story. So I'm going to put that in here. It's going to be difficulty, the amount of work, and then ambiguity. So if any of these go up, the story point should go up. All right. And so when you're thinking of these story points, so 1 is very easy. 2 is like 2 or 3 days, I would say. Don't quote me on this. If you quote me on this, they're gonna shoot me. Because people have always, it's always this stuff. It's not the amount of time that determines a story. Because remember, an 8 story point for one developer could be like a 3 story point for another developer based on their skill level. So you try not to make it based on time frame. You make it based on difficulty, amount of work, and ambiguity. But for practical purposes, let's just say on average, if you have an average developer working on this story, it should take them like 2 or 3 days to do it, basically. Okay. 3 story points is kind of like, and I'm purposely mixing them, matching them because it's not something set in stone. So like 3 to 5, 5 story points could be something actually. Let's just say 2 days. Nope, I can't. I mean, I'm struggling with this now. 5 story points. Let's just say it's over a week, right? And then 8 story points is 2 weeks, the whole sprint. Okay. And if you have anything above that, so like let's say you mark the story as a 13, then you're gonna be like, whoa, wait up, 13. If 8 story points is the whole sprint, then we can't get this done. The 13, we can't get it done within the sprint. So if you make it a 13, by the way, let's say you make it a 13, right? That means you're gonna have more than one person having to work on that. Basically, that's what that is suggesting. That it's so much work that you're gonna have like multiple people working on that thing so that you can get it done in time for the sprint. Okay. And then 21 and 32, I've never seen those in real life, but if there was a story that was just so huge, and you're like, we got to break this. This is going to be a 21. Then you can then take the 21 and break it apart, and that's like an epic at that point. You want to break it up into multiple stories. You do not want to take that on your sprint. Does that make sense? In fact, if you get a 13, if you evaluate something as a 13, you're like, yeah, this is going to take longer than 2 weeks. At that point, you should be like, yeah, we gotta put a hold on this. Let's break this story up into another story so that we can get it below the 8 threshold. Okay. So that being said, now that you understand all of this right here, right? Let's go back and plan. Let's actually go through an actual experiment. So, or let's go through an exercise here. So you have all of these things here, right? So they want us to implement and design all of this stuff. So that means we're going to have to hard code 4 species of bug, implement the dropdown. No, we don't have to hard code it. They want us to call the backend. They want to implement the dropdown. We can hard code 2 maps. Carousel, start the game, goes to the empty screen. Actually want to connect to backend, get the AI controller endpoint, update service logic, add the DAO method to get by ID. You want to create the table and you want to populate entries. What do you guys think? And put it all in the chat. Put your numbers on in the chat. We're going to do a countdown. This is actually called StoryPoint Poker. I'm going to do a countdown from 3, and I want you to put down which one of these story points you honestly think you would. I want you to rate that story honestly, okay? Over a sprint. Okay, so let's start it out. Put in the chat, okay? I'm going to start the countdown. 5, 4, 3, 2, 1. How much would you rate that work? And then Laura, can you please tell me what numbers are coming in? Please.
Yoon started us off at 32. Rob
Oh
says
my gosh. Oh my gosh.
Rob says 13. I said 3. Ethan said 1. Yoon really said 2.
You
Jeff
said 3? Oh my gosh.
Jeff said 8. Steve said 8. Chris says 13. Viv says 3. Josh says 8. And Ashley says 3.
Oh my goodness. Oh, I love that. This is a great example. Yoon 32. Oh my gosh, dude.
He was joking.
Yeah. I bet you with ChatGPT it'd be like 64.
Hey. More like 69.
3. So Laura, explain to me why you think it's a 3.
I was
You're a
honestly
beast.
just thinking that if I had 2 weeks and that was my project to work on, I guarantee you I could get it done in the first week.
In the first, okay, so if you were okay, so you can do it in the first week, but you want to take into consideration not just you, like you
Yeah.
want to take into the time constraints of like if you had to assign this to somebody else who you knew was part-time, then
Yeah, so like that was how I would rate it for myself. Like if I was judging that for my team, I would probably put it a little bit higher.
okay.
And not that my team aren't amazing, because they are, but time constraints.
Yes. No. Yeah, I get that. I understand. Yeah, and so I love the aggressiveness, but you just got to be careful because it can burn you. I've been very aggressive in the past with underestimating stuff, and it bites you because they don't care how good of a worker you are. They don't care how awesome you are. They care about results, and if you underdeliver, oh, it's the worst thing ever. Oh my gosh. So you gotta just be careful with that. Who said 1? Did somebody say 1?
Ethan.
Also as a joke?
Ethan said
I said if using Quasar and you're just doing the MVP, it would be 1 because you don't have to do all the playing around with CSS and it.
Okay. So even then, I would actually give it like a 2 or 3. If it was just an MVP like that and everything was hard coded, I would give it like a 3, because that's still some work in there. You got to do like, so when you go in here, you gotta actually set up the route for this, right? So you can actually go to that page. Then you got to do. I forgot to mention that. Then you have to do the carousel. So that's going to be another component that you got to work on. You got to do the drop downs of species. Yeah, that's pretty straightforward. You got to then be able to start the game and link that up. That's pretty straightforward. So you're looking at 1 or 2 points. But what we would like to implement also is testing too. So we have not done a lot of view testing. So we definitely want to be able to work that in. I'm not saying you should do it now, but we tech leads, you definitely want to be able to work in testing, because that is a huge portion of enterprise. The enterprise, like uh, everything everything is based on test coverage, high quality. Because remember, if you underdeliver, you're under the barrel basically. And on top of that, if I don't even know what that phrase means, but like you're on the gun, like they're breathing down your neck basically. If you have a shortage, or if you have bugs, or if you have the customers not liking it, like those are such the spotlight goes on them, and there's a lot. You have managers on top of that, you have support teams on top of that, so you're under a lot of scrutiny to make sure that you get things done perfectly. Okay, that's where the high stress comes from. So for the tech leads, not for the developers. Developers, it's usually pretty easy for them, but for the tech leads, you're the one, you're next on the hook. So you got to make sure that everything's proper and correct all the time, right? So yeah, that's why I'm saying with the testing, it should bump up that 1 or 2 to like probably like a 3 at that point. So that's why I'm thinking like maybe a 3 would be a good story. You can even make an argument for a 5, depending on the skill level of your team or the things that you have to research. In our case, We don't know testing, so we have to research the testing. So then I feel justified at that point to go from a 3 to a 5. So it'll take us about, I would say, like a week to a little bit over to a week to get it done, type of thing. And that's fine. It's all about expectations and setting expectations. If you can set the expectations to the customer and they think it's okay, you're good to go. And you can add a little bit of buffer there. Okay. Anybody else have opinions on this? Chris, I saw that you had 13. Why did you make it a 13? And how would you break it down so that it's less than 13? You there, Chris? Anybody else who said 13 who wants to talk about that?
Sorry, could you hear me?
Oh, yeah, go for it.
I thought was it for the entire list of actions or was it for a specific action?
All the actions, because that's the story itself. That story requires you to do all of that stuff.
Yeah, I said 13 just because the idea that I would want to split it amongst another person and you can
Okay.
kind of conquer the work a little bit faster and kind of fully flesh out not only just the actual implementation but the testing as well, and documentation and any refactoring that might be necessary.
Gotcha. Awesome. Very good point. So let's just go ahead. Let's call it an 8. Okay. Usually what happens in StoryPoint Poker is that people just get an average and everybody comes to a consensus like, okay, the 13 spoke, the 1 spoke, the 3 spoke. Let's just get an average. Let's make it an 8. And then everybody's like, okay, yeah, we can make it an 8. All right. So now that you have an 8 here, we're going to save this card. I'm going to go back here. And you can see here that we now have lobby screen UI development, story points of 8. And what I want to do is I want to now assign this to sprint 4. Okay. So now that we've done that, and then you keep doing that for the rest of your team. Like you try to figure out how many story points can we handle, and then you based on your team. Okay. So if everybody can do an 8 story, let's say everybody, you already know everybody, and like you've gained a lot of experience with them. You understand their work habits and all that stuff, their time management, all that. So let's say everybody can do 8 story points, right? So at that point, you can then say, okay, I have 4 team members. I already signed 8 for one. Let me see if I can get 3 more 8s in here. And that's how you try to figure out what you can commit to. Okay. In this case, because everybody's part-time, I would say like try to do 3 per person. That might be a little aggressive too. But try to keep things. You want to try to keep things minimal for now. But let's just for example's sake, let's say we have another one. Set up automated testing framework. Create an automated testing framework for the application. Ensure thorough test coverage to validate application functionalities. Oh yeah, so this is basically update GitHub Actions to run Maven test. I'm making stuff up here. What else do we have? Oh yeah, set up PR to run GitHub Actions. So I think this is the same thing. It's the same step. The question is like, do you guys even know how to do this? A lot of you should say no. I'm not even 100% sure how to do this. I would have to go research this myself, right? So how would you rate this story points? And remember, based on the 3 things of ambiguity, difficulty, and workload. So when you think of ambiguity, right? Yeah, I don't know how to do this. I got to research this, right? So this is going to take some time to research. So you want to factor that into the story points. The difficulty here is it should not be that difficult because it's just a command. It's just a command that you write in your script. So it shouldn't be that difficult. And then the workload, the workload shouldn't be that high either because it's you only have to do it once for your backend. So the biggest thing is the ambiguity and the research, and there is some difficulty with the research itself, but the implementation of it should be pretty simple. So that being said, we'll count down from anybody. Does anybody have any questions on this? So story setup automated testing framework. Anybody have any questions on that? Nope. Okay. Let's start doing a countdown. how would you rate this story? And remember, these are the points that you can do. So we'll start down from 5, 4, 3, 2, 1. Go ahead. And then Laura, can you tell me what kind of points are coming up?
Yep, Ethan is at 1, I'm at 2, Yoon is at 2, Chris is 2 or 3, other Chris is at 2,
Oh my
Berenice is at
gosh!
3, Rob is now at 2, I like his confidence growth, Josh is at 3, and Viv is at 3.
Oh, I was laughing so much because... Oh, I'm not laughing, but like, 2 is crazy! I think 2 is scary. I would actually go with like a 3 on this, but I love how you guys are, your confidence, just like you're saying, your confidence. And so the question is, would it take you 2 or 3 days to do this? I do not think it'll take 2 or 3 days. I think it might take like 3 to 5 days, but I don't think it's worth 5 points though. I think it should be like 3. But that being said, let's say I don't have to be. I'm not the. It's not a dictatorship here, right? If everybody's like 2, then all right, let's go with 2. But remember, if you can get 3, or I'll explain that in a little bit. So let's say it's 2, right? So I'm going to go ahead and save this. And so we now have a. Did I not save that? I'm sorry. Let's go back to that. Let's do a 2. Save it. Okay, so it's saved. Okay, so now we have an 8 and we have a 2, and I'm going to go ahead and put sprint. We're going to assign this to sprint 4. So now we've decided we're going to go with sprint 8 and sprint 2. Okay, so now I'm going to go to the sprints. I'm going to go to the sprint backlog here, and the lobby screen is way more important than this one. So I would want to make sure that this is prioritized at the top. Okay, and then what I want to do now that I've prioritized everything, okay, I then can go into my sprint task board, and then now I have all of the tasks set up for each of these so that we can then go ahead and get started. So we did a lot of covering there. So this is what we just did was the sprint planning session. Okay. Then the next thing what we want to do is we want to have our tasking session. Okay. So ideally it's with the whole team, but tech lead, like if you cannot meet with the whole team, at least do this by yourself. I mean, try to meet with as many people as you can, but you got to get the tasking done. The tasking is super, 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 super important. Okay, because this is where people are going to step on their toes if it's not done properly. Okay, so the tasking session is you completing all of the steps, or you writing down all of the steps that have to be done specifically for the lobby screen UI. So design lobby screen interface. There should already be tasks there for you that you can then modify. So I'm trying to make it easier for you. But when you create your own story, like you're not going to have any tasks there at all. You're going to have to go in and fill them out yourself. But as a way to just kind of give you some guidance and to help you out with some of the steps that you're going to need, I included them in here as well. Okay. So design the lobby screen. We'll have create the wireframes or UI designs for the lobby screen, including map selection and script assignment. So basically, this is just draw a picture, right? So I'm just gonna put draw, just have a picture. So this is where everybody can come together and actually design it. Okay. So you can assign this to an artist. Let's say you have a Chris Ratzabout on your team, and he by the way, he's a very good designer. You can just give this task to him, like, hey, can you please map this out for us? And so you can then assign it to whoever you want. Let's say Andrew's Chris, so we can give it to Andrew here, and then you can then hand it off and have him work on that. Implement map selection component. So this is the map carousel component that somebody can do. So this is the task for that. Create the script assignment interface. What is this? Build a user-friendly interface to assign scripts for each bug speech. So this is the drop down. Drop down component. So if you go back and look at this, you could say, okay, I want this person to work on this part right here. Okay, so this guy's working on the carousel component. This guy's working on the empty page that can then, and then he'll put in the 4 drop downs. So let's change this to create the lobby page and route it. I like doing this. Create the empty lobby page and route it. Okay, so let's keep this one. I'm going to change it all up here. So I'm going to save that. So this is Create the empty lobby page and route it, and then let's see if there's anything else. Create API endpoint, script selection, connect lobby UI to backend. Oh yeah, this is the full one right here. Nice. Okay. Implement map selection component. So we're gonna need another task. So I'm gonna add another task, and then I'm gonna say update skeletal page. So this is gonna then have to add the drop downs for the 4 species. And then I'm going to add the carousel component. Okay, so notice how this right. So let's, instead of calling it finish, let's instead of update, let's call it finish skeletal page. So we now have multiple cards here. We have to implement the map selection. So I'll give this over to the tester, and then create the empty lobby page and route it so I can work on this myself, right? And then now that everybody's assigned, now everybody can start working on this, and then you just move them along. So once these are all done, right? Once these are all done and deployed, they're now in resolved. And then all you got to do is just ask another member of your team, can you go back and verify that this actually works the way it's supposed to? They can go through, oh no, you don't have to do that. Sorry about that. So for tasks themselves, you can just complete them. Once you complete them, you just put them to the finish, and then you're done. Okay. You don't test tasks. You test stories. Okay. So a story has to be tested to make sure that you actually completed it. All right. But for tasks, you just move them to the end and you get it done. All right. I'm gonna have to I'm gonna have to like put like limitations on so that you know that you can't put in a resolve, that it'll just go there. But I'll work on that. So now that you have now that you're done with these, you just go back and then you finish the rest of these. And then once you get them all done, right? Once you get them all done, then you can then go ahead and say this thing. So let's say this is now active. But now that you got it done, now you want to resolve it. Okay. And once it's resolved, then somebody can go back and test it. And it says here, allows users to choose maps and scripts for each species. This is a horrible acceptance criteria. I'm going to update this to add more, but basically the tester can go in and make sure that it actually works properly. Okay. And then let me save that real quick. So any questions so far? Okay. Let's continue on with this. So like, and feel free to stop me if you have questions. So this thing right here, once it's resolved and you tested it and everything's good, then you can go ahead and mark this as closed, and then you are now done with this card. Okay. However, notice that there is a task still here. You should not be able to close. In fact, I'll probably hard code that in. You cannot close a story until all of your tasks are completed. Okay. So if you have a task out here still remaining, you got to make sure that you get everything done. And then on top of that, at the end of the 2-week sprint period, right? Let's say you did not get all of your tasks completed. You don't get partial credit for these 8 story points. If you do not complete the entire story, you get 0 points. Okay? This is where it starts getting crazy. This is where the drama starts building up if you cannot execute. You got to make sure you're executing. So you have to complete all of the tasks. If you complete all the tasks and you close your story and you have it deployed, you have 8 story points. That's great. Congratulations. You got a lot of points there. If you only partially finished it, okay, you get 0 points. If you have partial, let's say you did a lot of work. You guys did an amazing job. You did a lot of work, but you didn't actually complete anything. You end up with 0 points. That's, you are begging for trouble at that point. Like, you cannot do that. So this is why it's very important to prioritize. So here we prioritize this story at the top. That means everybody should be working on this. Everybody should be working on this to get this thing done. Okay. And if they, for whatever reason, you can't work on this, then you go on and you work on the next story. Okay. But you shouldn't be working on it piecemeal. You should be doing it more from a swarm perspective where everybody is attacking the top priority story first. getting it done, and then making sure that they work on the next one, the lesser priority one afterwards. And I mean, it's up to the tech leads. I understand you can have too many cooks in the kitchen. You have to use your judgment on that. If everybody's working on the one story and you have too many people working on the first story, it's okay to assign them to the second story and to the third story and so on and so forth. I leave it up to you to figure that out. But you got to remember, if you don't close any stories, there is no partial credit with Agile. You're going to get crucified if you have 0 points. So that's something you got to be very, very aware of. Cool. Any questions on that? And we have one more topic, which is the local dev and prod environments, and then we should be done for the day. But anybody have any questions? Okay, let me go back and cover all of the other stuff here. So you have your sprint planning and you have your tasking. So that's where you break it all down into tasks, and I just showed you all that. And then what you want to have your daily stand-ups. So daily stand-ups, I mean, you don't have to meet every single day. I'll just put it from Monday through Friday, right? Daily stand-ups are 15 to 30-minute meetings just to get up to speed. You don't even have to get on call. You can even just get on chat and just give an update for yourself. Like, that's fine. You just want to get into the habit of meeting every day. Oh my gosh. I want to make this pretty for you guys. Daily meeting. Okay, so you just want to make sure that that you at least meet up a little bit. Just give each other updates because you want to be able to communicate with each other. And you want to keep them short because if you don't keep them short, people are going to just zone out and not listen. Okay, so you have to try to keep these short. And I kind of say that jokingly because I know that some people might be zoning out right now. I apologize for that. But like, what's he get? I've been through so many of these meetings. And yeah, do not zone out. Try not to zone out. It's very hard, but do not zone out because it's just a waste of everybody's time at that point. Okay, so you're gonna have your daily meetings here, and it's up to you, tech leads, how you want to do it. If you want to meet up and do it's called stand up. If you want to do it through chat, you want to do a stand up, it's fine. But just make sure that people are being able to give your updates on what they're working on. And the reason you want to do this is you want to see what everybody's working on. You don't want people stepping on each other's toes. People can be moving. This process allows you to move so fast. It's so fast. You think it's unreal. Like you're like, how the heck did they already build? Somebody already built this. Somebody already built that. What? Like it is so fast. It is very exciting. Okay. So if you're on a team that has high velocity, that's what velocity is. So if you have a lot of story points per sprint that are completed, that's what's called your velocity metric. That's how many story points you can complete per sprint. And it's not a competition. Managers do not try to compare sprint points with other teams because they don't make any sense. Like you can have this high level team that is making it because it's all relative, right? A story point for an expert might be a 3, whereas for a junior it might be like a 13. So like that's why they don't like comparing story points within teams. Sometimes it happens though, and everybody always gripes about it, but it's a common known thing that you shouldn't be comparing teams based on velocity, even though there's always a suspicion that they are. But that being said, like the velocity is there to evaluate you as a team. Like, are you consistent? Are you want to get rid of the ups and downs? You want to be consistent so that managers can better plan for the future with their roadmap and all of that. Okay, so it's all about consistency so that it's better to help the management plan out the project. Okay, so let's go back to this. So the daily meetings, here's the daily stand-ups, and then finally on Saturday again, we're going to have what's called the demo. So we'll be repeating all of this stuff again. Actually, it should be Friday, but we should do it on Saturday, I think. So this is where you actually demo to the customer in the morning. So we'll demo. So that'll be the customer. You guys are going to be demoing to me.
I have a
Okay.
question about that.
Yeah, go for it.
So, like for this sprint, our first 3 that we were assigned was the backend repository, front end repository, CI/CD
Yeah.
pipeline, and then my team is also working on registration and login.
Oh,
What all
careful!
are we
Don't tell me that.
demonstrating? Okay, I didn't tell you that because if it's not working, I already
Yes.
talked to them about we're going to hide those
Yes.
cards and
Yes.
pretend we didn't do that, so you didn't
Yeah.
know.
Yes. 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 Good. Don't tell me because it's all about setting expectations.
Okay, well, we're
So,
going to set the expectations that by next Saturday, our CI/CD pipeline, our front-end repo, and our back-end repo are just perfection.
exactly.
How do we
Good.
demonstrate
That's
that
what I
to you?
want. You just show me just show it to me working. Like, show me a link. Show me a link that shows it live, and I'll be happy. Show me the backend, like through Postman. Show me through the backend that you're connecting to it, and and it works. I'm happy. It could be a dummy endpoint also. Or you can get a little fancy. You can have the UI. You click a button on the UI, it calls the backend, and then it displays the response from the backend.
Okay, great.
Because you gotta deal with cores there also. So that's another issue. If you can even do that, like that's awesome, right? But from a customer perspective, all I really care about is just getting everything set up.
Okay, great.
Yeah. So and that's cool that you're working on the authentication piece and already and all of that. But don't tell me sandbag that. Because then that gives you more strategy to figure out the following sprint. I feel bad telling you that because I'm like basically saying, "Oh yeah, I lie," but
No,
I
no,
just been
it's
bird.
it's teaching us to build expectations in a work environment, and I actually think that that's super duper smart. We just kind of had the too many cooks in a kitchen problem, and
Yes,
honestly, it was a way that I could give my team things that they could actually work on that were visible after they went through all of the research and building up. I mean, I have 2 team members that have built entire dummy projects of their own like this just so they could see the process.
awesome. Very smart. Very smart. Yes, very good. Yeah, you want to be able to do that. And the reason I kind of feel like I'm like that salty, jaded guy, like saying like, "Oh yeah, it's so stressful." Blah blah blah. Like I apologize for that. I want to be positive. Like this industry is amazing. You're gonna get a lot of benefit from it. I have 2 different clients, so I'm already I have voluntarily overworking myself, and so take my griping as with a grain of salt, because
Um,
I voluntarily chose to do this,
No, it's really
and
easy to overdo yourself on this. I mean, by Wednesday night, my team could attest to the fact that in our stand up, I was a zombie and I could not even speak coherently. And so I took Thursday and I did the stuff I needed to do and I had some self care. And let me tell you, Friday was way better.
oh, that's awesome. Yes, yeah. It's just I sometimes I go on fumes, so if that is the case, I do apologize for that. Uh, I care. I want you guys to be successful. Um, and I'm trying to also pay off my house because I want to get my goal is to get Crusader Games up and running so I can work on games full time all the time and not have to worry about bills or anything like that. Like if I have to go long time frames with very little money, like I want to be able to do that, and that's why I'm working so hard. So that there's a reason for why I'm doing it. So uh, but thank you for your patience and flexibility as well. But that being said, yeah, if I sound jaded, yeah, it's just because I am stressed. So, and I want to protect you. I'm just trying to give you the nuggets of wisdom that I've learned of, setting expectations. Setting expectations is huge. So I'll just leave it at that. Okay. All right. So yeah. So now we got the demo. Now we have sprint planning. Now we have, and then you just repeat the process all over again. Okay. Um, there is a meeting that you should be holding here. Shoot, man. Like, okay, we really should be doing demo and retro like on the Friday. Oh, okay. I'm going to show you how it's supposed to be done, and then we can then figure out if there's a way we can incorporate it or something like that. But so let me just take this out here. So what you really should be happening is your demo should be having it on the last day of the sprint. So it should be taking up the daily meeting here. You do the demo with the customer. And then at that point, you then have what's called a retro. And tech leads, I can have a retro with you guys so that I can show you what that's. Well, we'll go through it right now too, if you guys have time. So we have a retro here. So you have the demo, and then you have the retro, and then here the sprint planning and tasking is. You just repeat the process here. So let me just copy this over, and then replace this, and then you just keep on going from there. Okay, so that's pretty much it in a nutshell. The demo is the thing that this is the show right here. So you gotta have everything already deployed. You gotta have everything ready to be shown. You're spending like these last 2 days getting ready for it. It's like it can be a high stressful situation, and you want to make sure that you're putting your best foot forward on this, right? This is the point where the product owner will be the one talking. Sometimes they'll throw the developers into the back of the room because the developers might say something stupid. It's like it's great. Like it is. It's high stress. Like you can't mess up here because you're talking to the customer. All right. So it's usually the product owner that's giving the demo, or if I would say like 50-50 chance, and then the developer, they'll have like the tech lead give the demo here as well, or the tech lead will say, you know what, I want to showcase all my developers we want to highlight to the customer that everybody's taking part in this and everybody's working, so they're getting their money's worth. So I'll have each developer give a portion of the demo. So like I'll leave it up to you tech leads to figure out how you want to do that. But like this is a sales presentation here. Like you are assuring your customer that they are getting value for their money, because you guys are all expensive. You got to be able to show them value for all that money that they're paying out. And then after the demo, which typically like 2 to 5 minutes, it's not that long. 2 to 5 minutes long. Okay, you answer questions, in which would take longer than the actual demo itself, and then everything's cool after that. And then the retro after that is like a 1 hour long meeting where everybody just vents. Everybody talks about the entire 2 weeks and how they can fix and address things to make things better. Okay. This is where you get the popcorn. This is probably my favorite meeting of all of them, because everybody gets to let loose over here. This whole 2 week time frame has been all about coding, deadlines, stress, getting it all done. The retro is the time for everybody to vent, chill out, enjoy themselves. You can even leave early during that day. I usually do that with my team. Like, I don't care what you guys do. If you want to work, great. If not, have a great weekend. So like this part right here is all about like, it's all about like what you were saying, Laura, taking care of yourself. Everybody at the retro, everybody calms down. Everybody's cool, and then we start again on the following week. So the sprint planning and tasking is usually on a Monday, right? Or sometimes they send them on Tuesdays or Wednesdays, but everything's done over a 5-day work week. We're doing 7 because it's part time. So I'll let the tech leads adjust for this as well. All right. And then tech leads, we'll talk about when we want to hold demo. I mean, if we want to do a Friday thing, we can. If we want to try to do it Saturday, we can also do that too. I'll leave it up to you guys. We can talk about it in the chat. Anybody have any questions on this? This is pretty much Xtreme Programming. Oh, and then let me just Xtreme Program. That's the schedule. And then last things, Xtreme Programming requires pair programming. So I'm thinking you guys are already doing that for the most part now, but Xtreme Programming requires pair programming. And the reason I like that is because it helps the experts teach the juniors. Okay, so you can have like seniors teach the juniors. You can have like the rock stars teach the newbies, right? Like everybody is helping each other, and not only that, you might have a view expert working with the backend guy, right? And they start teaching each other their own paradigms, and so that's where so all of with the pair programming, all of the knowledge is spread throughout the entire team, and it builds camaraderie with everybody. So pair programming is extremely important. So please do that. Try to work as pairs, and one person can take a turn writing code, and the other person can dictate to them what to do. That's one's called the driver. So one guy is just typing and that's it. And then after an hour, you guys can switch roles, and then you can then have the other person type, and then that person can dictate what to write. And you're always shooting ideas off of each other. Okay. So that's pair programming. The next thing is testing. So we do not have a lot of experience with testing. I try to teach a little bit of testing at Tech Elevator, but it's woefully inadequate what I taught. Like if you want to be enterprise level, you need to understand how to write unit tests and integration tests. Okay. So we're going to put a strong emphasis on that. And part of that is called test coverage. So eventually we're going to have the tech leads incorporate test coverage as part of the PRs. So that means that when you try to submit a pull request to get your code merged, we're going to run the tests. And if you don't have 80% test coverage, that pull request is not going to be acceptable. You're going to have to then write more tests to increase the test coverage so that you can then be able to submit it. Okay. And that's pretty much it. That's all of Xtreme Programming. Any questions? Okay, no questions. Let me just clean this up a little bit, and then we can post this as a graphic for everybody. Okay. All right, let me just crop this. There we go. And let me save this. All right, now we're going to talk about development environments, and then we should be done. So 15 minutes. Okay, let's do Xtreme Programming. Okay, the last thing we want to talk about is environments. Okay, so an environment is, so when you guys go to render, right? You guys are given a website. Oh, let's talk about American Airlines. So I used to work at American Airlines for one of their Miles project. So if you actually go to aa.com/miles, you'll see work that I actually did. Okay. And American Airlines is a huge company, huge application. Like I was working on not the American Airlines website. I was working on aa.com/miles. I think that's what no, that's not it. I have to actually look it up what it is. So like I was working on a directory of the application. I was not working on the full app itself. Like the full app is too big. So if you go to buy miles, where are we at here? Earn 1,000, 5,000 bonus miles. Nope, that's not it. You can see there's a lot here. Let's look up miles here. Buy miles. Yeah, buy, gift, and transfer miles. So this is the portion that I worked on right here. So notice here it's aa.com, AA Advantage Program, miles, buy, gift, and share miles. So this app right here, this is written in Angular. This app right here was what I contributed to this. Okay, so notice how this is at aa.com, okay? But this is the production environment. This is what the customers see. But what I actually saw when I was actually writing the code is different environments. So what do I mean by an environment? So when we wrote our code, we would update it and deploy it to dev.aa.com.
Mm-hmm.
Okay. And so dev.aa.com is another domain within the American Airline like network that represented the actual website. It was like a live copy of the website, but that only we can see it, the developers. Okay, so we would use this as a testing site. Like I would deploy my changes, right, and then I'll go to dev.aa.com and then see in real time how my code, how it changed, and if there was any bugs or whatever. And if everything was good, then I would then say, okay, I'm good to go. My story is complete. I am now going to send this to the UAT team, and so we would then send this over to uat.aa.com. Okay, so this is another completely different copy of the site, but this had all of the completed stories. Okay, and so all of these completed stories, the UAT team, this is the quality control team, they're the testers, they would then go through and make sure that your stories were working in proper order. Okay, So let's go back to Crusader Games here. When you go to, so when you go back to the taskboard, right? Let's say this story was completed, right? I would have this story as resolved. Okay, and then I would assign this to the testing team. And so the testing team would then take a look at the lobby screen within uat.aa.com, and they would just go through and see, does this allow users to choose maps and scripts for each species? Yeah, it does. And they would just mess around with it a little bit, make sure that everything's working properly. And if it does work properly, then they would be the ones that says, okay, we can close the story. Okay. So when it comes to environments, there are different versions of the site environments. There are different versions of the website, of the web application that are not, ideally, they're not viewable, ideally, are not viewable by the customer. Okay. All right. And so we're actually going to have two environments. Okay. You're going to have your, well, actually, there's three environments, but there's two that are deployed. There's the dev environment. So I want you guys to have eventually, and you guys can work on that this week if you can. You're going to have a dev environment, which is going to be a UI. So it could be something like bug wars healer dev.render.com. Okay. And then you're going to have a backend URL of bug wars healer dev. Oh, this one should be UI. No, it shouldn't be UI. This should be dev. This one should be backend. Dev, or let's do backend dev.render.com. And you don't have to use render.com. I'm just making stuff up here. Okay. So the way this works is if I go to the UI bug wars healer dev render.com site, right? Like I get to see the UI of all of the newest changes that you're currently working on in the sprint. Okay. And then when I click on a button, this guy should then call the backend also hosted in this dev URL. All right. So this represents one environment. All right. And then you're going to have the prod environment, which is going to be the custom. This is what, and by the way, this is what you demo as well. Okay. Prod environment is what the actual customers see, what the actual gamers see. Shoot. I screwed that up. Gosh, dang it. Dang it. Why did I do that? Just do it again. All right. So let's see here. Prod environment is going to be, you guys can choose your own. You just got to tell me what's prod and what's dev. So your prod environment is going to be, so prod environment. Gosh, why is my keyboard acting crazy? Environment. Oh my gosh, prod and what? Prod environment. Okay, will also be hosted at a different spot, but this is like your real site. So if you wanted to buy like a domain for this, this is where you would buy it. Like this is where it'll be like www.bugwars.com, because this is the place that it's actually going to live. This is just a practice site, so we don't have to do that. But this is the place where it'll be bugwars healer render.com, right? This is the real site. You don't have to add prod or anything like that because it's supposed to represent the real site. And then you're going to have bug wars healer backend render.com. Okay. So the prod environment is going to have the UI hosted here, and then you're going to have the prod environment with the back. So you're going to have 4 instances of your app running. One UI in the prod, one backend in prod. You're going to have a UI that represents the dev, and then the backend that represents the dev. And then there's one final environment, and that's called your local environment. So your local environment represents you running your application on your computer. So that's why I said there's actually 3, but only 2 are deployed. The local environment is all of the configuration necessary to run your UI. So this is localhost. I think it's 8080. It depends on what it is, 4200, 3000, whatever way you're running it. So it's localhost 8080 for the UI. And then the next one is going to be localhost, let's just say 9000 or 8080 is the backend. I'm going to use 3000 for the UI. Let's just do that. It doesn't matter. It could be whatever you want. I don't care. But this is kind of like how it works. So in the local environment, you're running this locally in the UI, and then you're connecting to the backend here. Any questions on this so far?
So when we demo, we're gonna demo on the prod environment, and then
No, you demo on dev environment. This is the version you demo.
Oh, okay, on dev environment. Okay, that was
Yeah,
where my
and
confusion
this is
was.
the version you're working on. Okay, and this is the one that this is always run. This is the customers, and then once you're done with the demo and everything's cool, then you deploy it so that this thing will now run in here.
Understood.
Yeah, this is called the release. So after you're done, so after all approved, deploy dev or deploy all changes to prod. And so this is why you have to have your pipeline set in place, because you're going to have some sort of, you want to configure some sort of button or some kind of a button that basically is, I push the button and now I'm going to deploy all of my changes to prod, and then it'll be on the real time thing. So this is cool, right? This is real enterprise. This thing will always be up and running. You can always have interviews and talk to people about this one, right? The dev environment you can break because everybody's working on it, but this guy will always be running. And then once you get this one working and everything's cool, then you can go ahead and move those changes up in here. And then locally, you're coding locally, and this is just where you're running stuff on your local machine. But once you merge it and deploy it, you're going to want to have in your pipeline the mechanism to then auto deploy the accepted PRs into here so that it's running live, and then everybody can see those changes as soon as they get there. Any questions?
So when we do our pull requests, should we have it set up to require pull requests for the dev environment and the prod environment, or just the prod environment? Or
Okay,
is that like
this
a
is
choice thing?
no. This is where it can get confusing. Okay, let me try to map this out here. Okay, okay, so when you're doing the pull request, everything's going into dev. Okay, so let's talk about branches. I don't like dev environment. Let's call it something else. Let's call it QC. It always confuses me. It always confused me, and that's why I want to change it. Because dev and there's a main branch and there's a dev branch, and they're not the same as prod. And so we're going to call this staging environment. Staging that's also very typical. So we can call it staging. Staging environment. Oh my gosh, what is wrong with my keyboard? Staging environment. Okay, so this is the staging environment. We can change this to staging if you want. We probably should. Oh, this is staging environment. Okay, just know that it's not dev. Don't try to call it dev. Like, let's call it staging, because there can be some confusion here. So we have our repo, right? So we have our repo branches, and so your branches are going to be, you're going to have a main or a master. So let's just say master for now, but you can call it main if you want. Master and dev, okay? So you have two branches. Dev is the one that is your real work is this one. So dev points to this, okay, and master points to this, okay. So everything that you're changing is going into dev. As soon as you are ready to go with dev and you want to actually get it over, you want to deploy to prod, you then merge dev into master, and then master gets built and deployed into the prod environment. Does that make sense?
Yeah, that makes sense.
So master is never hardly touched. Master is only touched when you are getting ready to deploy to the customer branch. So all your PRs are going in here to dev.
Okay, great.
And then, yeah, all your PRs are going here to dev. This is your main one, basically. And then once you're ready to go, then you merge dev into master, and then you build master and put it into prod. This is not really the way of doing it. This is just me explaining it in a very easy way. What really happens is you have what's called an artifactory. I hope this doesn't get too confusing. If you can set this up, that's even better. Like, this is the type of stuff that sets you apart from other junior devs. You're not junior devs, you're full stack developers, but I'm just saying, like, this is you're gonna see, like, yeah, I'm not a junior dev, I'm a full stack developer. Because this is the stuff that sets you apart. So like an artifactory, okay, is, let's say you're a staging environment, right? And you are good to go. So let's say I'm gonna use exe. So you know how in Windows, if you want to run a program, it's called an exe file. Let's just call it a jar file. So like in Java, since we're doing a Spring Boot app, you generate a jar file that then gets run in the cloud because that's your website. Okay, so I can start out with version 1.00.jar. Okay, so let's say I start out with this. I start out. I create my Spring Boot application. I have a jar file, and then I deploy it. So what I do here is I take that jar file. I take that jar. So don't even look at the master dev. I take that jar file and I push it into staging environment. Okay. And then once I demo it to the customer and they're happy, they're like, okay, we like this. We can go ahead and release this. You take the version 1.00.jar file and then you put it into prod. It's that easy. You just copy that file and put it in prod, and then you run it from prod. That's how it's supposed to be. Okay. We have it set up a little bit different. But you take that jar file and then you save it. All right. Now let's say you have a new version of it, right? So let's say it's version 1.0.1.jar. Okay. And so this is your artifactory. And all you're doing, this artifactory is just a fancy name for a place to save all your jar files. Okay. So now that you have version 1.01 here in your staging, and then you demoed it to the customer, then all you got to do is just copy version 1.01, replace version 1.00, and then you now have it running in prod. So you're never running, you never touch it with code. You build it once in the staging environment as the jar file, and then when you're ready to deploy it, you can then push it up to prod and you're good to go. But why would you want to have master and dev? Okay, so let me explain why do you do it this way? The reason you do it this way is, let's say I release 1.02 now, right? But 1.02 has a bug in it. It has a critical bug, and we cannot let that thing out there. It crashes stuff, right? So I have 1.02, I have it in develop, I demoed it, everything's cool, but then I copy it over to prod and I'm running it, and then things just blow up in prod. We don't know why. Something blew up. And so what you want to do with that is you want to do what's called a rollback. So instead of having to rebuild master and do all this craziness, right? All you got to do is take the version 1.01 jar and copy it over the version 2 jar, and then you have it back up and running again perfectly. Does that make sense?
Yeah, that makes brilliant sense. That's amazing.
Yeah, it's awesome. So this is the artifact. This is how you have your jars stored, and so let's say that happened, right? Version 1.02 was uploaded. We got to roll it back. We got 1.01 now. The reason we want to keep it, the reason we have master, so you have release branches too, but if we kept it, so if we keep master as the prod environment, right? And we notice that there was a bug there, and we just can't. This code is now filled up with all the new stuff from the sprint, right? So that's why you want to have the master that are pointing to this, or not. You want to have the master have the code that's of whatever's being released, so that if there is a bug and you have to go back and fix it, you have that code right here to fix it on. Okay. So let me give you an example here. So like, let's say we deploy to version 1.02, right? And this in enterprise, it takes like weeks to do this. It's not like a simple click of a button yet, even though everybody wants it to be that way. There's just so much bureaucracy that you're not going to be able to do it so quickly, right? So what happens is, as I'm deploying version 1.02 to prod, I already demoed like a week prior, and then it took us a while to get everything already staged. So a week later, we're going to deploy this, but then we're already working on our sprint. So we're already changing dev with all of our new stories and all of our sandbagging, right? Like all those authentication stories that you were already working on, we're already pushing up to dev to make sure that we got it ready to good to go. So like when this thing's deployed and master has this code, but then dev has our sprint code, they're not the same at that point. And so if we want to do a hot fix, if we got to fix 1.02 fast, right? We still got to test all of the dev code. We can't do that. So what you do is, at that point, because these two are separate, you apply the hotfix to master at this point. You rebuild master, and you can call it like version 1.02 hotfix or whatever. I don't know, whatever code you want to use. It should be 1.03, but anyways, you do some code. I'll just put the H there for hotfix. So you deploy directly to master, you build master, you create that new jar, and then you redeploy to prod. Everything's good to go. You're still working on the dev. The dev stuff does not interfere with that. So that's kind of that's one of the issues that you got to deal with deploying stuff is you got to be able to get to the original code, which is a master, adjust it very easily, right, with the hotfix, rebuild the artifact, and then push it back up to prod, and then you're good to go. Because master and dev it's not always straightforward. Like dev is going to have all your new sprint changes, and sometimes you don't want that there if you're trying to apply the fix to only the customer code and not your new stuff. That makes sense?
Yeah, that makes sense. I know when Ashley did her write-up, she had a whole section on hot fixes that was really cool that kind of explained it really well.
Oh, nice. Cool. Awesome. Good job, Ashley. Yeah, please share that out with everybody.
Oh yeah, she made an amazing Git write-up. Oh my gosh.
Awesome. I'll have to check it out. Does anybody have any other questions? I think we already went over very far ahead, but I think we covered everything. This should be a great recording for everybody. Get everybody up to speed. But yeah, any questions?
I think everyone's head is spinning just slightly.
Yeah, I know. I bet you everybody's hungry too. Okay. Well, we're gonna go ahead and post this up. Probably, so I'll probably post it up sometime tonight. Thank you, Laura, for recording. And yeah, just get fired up, guys, because next week when after the demos are completed, like the floodgates are going to open at that point. There's going to be all the frameworks going to be set in place. You're going to have the story set in place, the tasks set in place. Your tech leads all of you guys are going to be working at the same time. Things are going to be moving fast. Hopefully you don't step on each other's toes, but I kind of hope you step on each other's toes so you learn how to deal with it. Like all of this is part of the growing pains of working in a team, and it's very rewarding. It's awesome when everybody's working together and you just see the progress fly by. Like it's very exciting. So that being said, you guys have a great day and a great weekend, and I will talk to you guys on Discord. I'll let you know of any updates. You guys have a great weekend.
Have a good weekend, Jerry.
Thank you.